Hello, in this video I'm going to be working on adding dead code elimination to my Rust compiler module. This project Rust C code CLR basically allows the Rust compiler to turn Rust code into .NET assemblies which can then be loaded by the runtime. You can also use them as libraries from C#, but currently I have a bit of a problem. Mainly the generated assemblies are very big. Like here this is a very simple like hello world program, and it weighs around 8 megabytes. That's not very good, and also it makes debugging quite hard because the file that contains the basically when I print the representation of the assembly, because .NET assemblies are written in what is called the common intermediate language. So when I open a CL file to look at the intermediate representation, is so long that it tends to make my editor a bit sluggish, and I would like that to not happen. So basically dead code elimination is removing functions that are not needed, or in more general it's just removing code that's not needed. I am going to be removing mainly functions that are not needed because this is the very easiest form of dead code elimination, and it is also like relatively good. Like it's good enough for my use case. Like it should cut down the assembly size significantly without requiring all that much effort. So the algorithm I'm going to be implementing is kind of inspired by garbage collection, or more specifically copying garbage collection. So basically I will be assuming how garbage collection works is that you have the stack on which you have some references to objects, and those objects are alive, and then you go to all the objects that you know are alive and you see what else they reference, and then you copy those too. So you copy only the things that could be reached from. So in my case, first I will start at the program's entry point, so at the main function, and then I will see, okay, what does this main function call? Does it like in this case, I don't know, here this function called, this is one of the functions in my test, it calls this function, so this function is alive. And if I had a function through here that's never referenced, I would like to remove it. You may be wondering, doesn't the Rust compiler do that by default? Yes, it does, but in a more limited fashion. Basically, the Rust compiler doesn't do that. Like since I am replacing the last part of the Rust compiler, it only does some of the code elimination. I have to do some of that myself. Basically, it doesn't remove code that could be referenced from another crate. So like for example in STD there are a lot of functions, I don't know, related to networking. This test doesn't use any networking, so it shouldn't, those functions shouldn't be bundled with the executable, but they are. So that's something I would like to, okay, this particular test doesn't use the standard library, but I can open the one that uses it. Where is it? Source code here. As you can see, it does use a bit of the standard library, but not things like networking, not things like, I don't know, it doesn't use some string compilation, it doesn't use some things related to iterators. So there's a lot of the standard library that's not needed, but it's still there, and I would like to eliminate it. So that's called elimination. And the algorithm I'm going to be using is like inspired by garbage collection. Basically, we will start with the root, which will be the main function, and then we'll copy only those functions which are referenced, and then we will have a list of those functions which are needed, and we will not copy anything that's we'll copy everything that we need, and we shouldn't copy anything that we don't need. Okay, so basically, first of all, we need to tell the linker, because I have also written a linker, custom linker for this project. it basically consumes the files created by the project and then turns them into one final assembly. So this is the stage at which we should be. It does like a bunch of other stuff, but this is the stage at which we should be doing it. For example, it does a bit of cargo integration, like it needs to do some stuff to make cargo work with .NET. It's kind of it's like creating a small wrapper Rust program which will basically invoke the .NET runtime for cargo. So cargo doesn't know anything about .NET, so I have to do a bit of like dancing around it to make it understand, like to make it able to use the .NET runtime. So before we export the assembly, I would like to remove that code. So we'll do final assembly though. And then we'll have to implement this function in. So now also we would like to do this only if the final program is not a library, because this is a bit more complicated for libraries and it would require slightly more work, maybe mainly detecting functions that are externally visible. So it will require a whole song and dance. For now I want to do this just for standalone executables, because this is it's a good proof of concept. So if something is not a library, only then we will perform that called elimination. In the future, when I make it a bit smarter, when it's able to understand things like external functions and non-external functions, like functions that are visible to other code, then I maybe like change this, but for now this is good enough. Like this is only a small proof of concept and I'm implementing this. This has like other benefits. For example, it makes the just-in-time compiler do less work, and because of that it can focus more on compiling the relevant functions. The just-in-time compiler, it works on like it compiles stuff as it's needed, but still, because I'm making an assembly smaller, it's going to be faster to load overall. Like the just-in-time compiler, I misspoke there. Like it's not better for it, because it only compiles the code it needs, but it's better for the final assembly size and it's better for debugging purposes. So it makes finding stuff easier. Okay, so in assembly we'll have to implement a function eliminate that code. And here we have a function that it will take if you are wondering like why are the backslash there, I'm currently on the newest nightly Rust version, which in which the Rust analyzer has a small bug. It basically inserts everywhere it sees a brace, it also inserts a backslash. That are the quirks of working with a nightly compiler, and I have to work with a nightly compiler because I have to constantly fix stuff up, and I also have to. You can't use the APIs I am using without having a nightly compiler. That kind of sucks, but oh well. What are we going to do? Okay, so the basic idea, first of all, we want to have a collection of objects that we are currently checking. I plan to have like 3 categories of objects. The objects that are alive and already added. Maybe it should be a hash map, because I'm pulling stuff out of a hash map. So we have objects that are alive and objects that are currently, I'm calling them that are currently being resurrected. I'm calling them no, I know zombie. No, like. So those are the objects that we have that are alive, but we haven't checked their references. Like those are the objects that are fully checked. Basically, we only check this is for performance reasons. Like we could check all the references within the alive objects, but I plan to, like, we could recheck them again and again, but we only need to check the new references, and here will be all the new references. And first of all, we'll set those to the entry point. We have a we'll get methods, oh no, functions, self.functions, and we'll then get the entry point. We'll have to unwrap it because we know that this is like always. Okay, maybe we should separate this into a separate function. We can have a function called get external functions, and this function we will return as a hash map of the call site. Basically represents the function's signature, its name, and is it static, like all that stuff. Like it contains everything besides the actual operations that make up the function, and this is what is used to look up a function. And we basically for now create a new new hash map. And here in the future, like I can add like actual external functions. For now, I will only add the entry point, because once again, this is a very simple version of the actual algorithm. Okay, so if there is an entry point, they will add two externals. We'll add the entry point, and we'll also look up in functions the entry point. We'll get entry point. Okay, so here we also have to clone and unwrap. Okay, what is the complaint? I unwrapped. Huh, kind of weird. And here return. Okay, so we'll just the lag. What's your issue here? Okay, so here I have to have a reference, and okay, so I also have to clone that, and voila, everything should work out just fine. Okay, so here we'll basically first get the external functions. So this is the very first initialization step. So oh, this is okay. This function does something very different. It tells the linker what are the functions that the assembly references, not the functions that the assembly like exports. So maybe I should rename this to get exported. Functions, because like the entry point is one of the functions that are externally visible there and exported. Okay. And then for each function in the resurrected set, first of all we want to add them to alive functions, because well, we are like resurrecting them. And then we want to go to all the other functions they reference. For reference in function dot. Okay, so we want to get the second part, and here we have a useful function called call sites, and it will basically return us all the external references. And here we want to insert the key will be this. Well, we also have to clone that. It's not very good. Okay. You may be wondering why I am cloning that. Okay, I'm currently trying to, because in this loop, while we are going through the functions that we are resurrecting, we are creating a new list of them. Maybe we'll call them this list to resurrect. This is kind of, may seem kind of complicated, but this algorithm is, in reality, is quite simple. Basically, we need to go through all the functions we are currently resurrecting. And yeah, maybe I should rename that to resurrecting. I don't know. To all the functions that are currently being processed, we first add them to the alive set. Then there was like a helper function in method that I think returned all the returned like a reference to an iterator over called sites. Maybe I remove it. Oh, calls. Yeah, and this basically returns all the functions that could be called by this. So it's called calls. Okay, and then we'll add it to the list of the functions which will be getting resurrected in the next iteration. We'll add them to the to resurrect list. First, we'll also have to do a bit of filtering. So if the reference if it's attached to some class, then we know that it will require a bit more, that it's not a method that belongs to the main assembly. Oh, that's actually. In the future, I will have to. For now, I will just ignore them. But in the future, it could be possible that a type references that a type, for example, a user may define a type that's a reference that references a function that's contained in the main module, because basically all the Rust code is stored in. Okay, if I, for example, build one of the tests, because I currently this does not have a type specified. Okay, so here we'll basically add soon. I just have to patch that up before the reference. Then self.functions.get reference wrap. Okay, that's a issues. Okay, here and here. What's your issue? Functions one does not live long enough. Why? Why does it not live long enough? If I do something like that, will it live long enough? No. What's happening here? Okay, binding declared at line 589. The borrow is used at 595. And it's dropped at 598. What? Once again. No, it's declared here, and it's dropped at 598. Oh, because this has the wrong type. I just have to clone this. And yeah, no. And ref method. Oh, so this has to be cloned. Here. What's your issue? This should not have any. Oh, borrow of moved. Okay, so we can have this should be also our reference. Why is it moved? Calls doesn't. It takes a reference. So where is it getting moved? Oh yeah, because I have to clone that. Okay. So now I have a bit of a skeleton. I can build this test and show you how and explain the way functions are stored, because it's kind of important to get why I'm doing things a certain way. Okay, so when we'll open this, this is the common intermediate language. And here you can see a class called Rust module, and this class basically stores all the functions in it. Like this is where all of the Rust functions are stored, in the Rust module. But some types also have their own functions. Like here you have a type. I know this function is for debugging purposes, so it's not relevant, and it can't call anything else. Basically, in the future, some types could contain references to the Rust module class. Currently, they can't do that. Like, it's not forbidden, but I never do that. But in the future, I could do that. So here, I can have to do if save. If that code elimination is too aggressive, check if track this methods referenced by inside types are not. Okay, so basically a small reminder in the future if I'm curious, like if this fails and I'm searching for an issue, I want to have a little note that explains what's happening here. Okay, so basically if a function has no class, if it's attached to if it's not attached to any class, it's assumed to be attached to the Rust module class. This is basically a small memory saving trick, because most of the functions are attached to this Rust module class. Because of that, I am 100% like, it's way more efficient to not save that information and use the non-variant here. In the past, they were attached to the assembly itself, but it posed some issues. Like basically, some of the compilers I used didn't want to show them, and really you shouldn't attach all that many functions to the module, like to the assembly itself. You should attach them to classes generally. This is what all the languages in the .NET ecosystem do, so I decided to just do that and not to think too much. Okay, so now when a function is getting resurrected, we first add it to the alive set, then we if it's a function that belongs to the Rust module, we add it to the toResurrect list. I want to add one more check here. I want to also check that the alive set doesn't already contain it. If the alive set contains the key, like this reference, then we want to ignore it, because this function is already alive. We could also check the current functions that are being resurrected. Contains key, the exact same thing. This is a relatively cheap lookup. And resurrected. Okay, we could have a reference to this, and okay, this didn't change all that much. No, it changed the way I have to now clone this too. Okay, and with this, we now have done one iteration of the loop, and then while there are some functions which are being resurrected right now, this will repeat. And at the end of this, when we traverse to all the functions in the list, in this list, the very next step should be to I will quickly format this. Oh, syntax. A syntax error issue. Did I delete too much or too little? Okay, so I deleted too much. Okay, this is why I prefer to have this formatted. It's like a quick, dirty solution to a simple problem. But what's happening here? Okay, so now it's too many. What did I mess up here? That makes sense. What is... If I do that, will you be happy? Do I have to... Okay, let me quickly reformat that myself in order to see where the issue is. Okay, this seems to make sense. Yeah, this makes sense, this makes sense, this makes sense. What is your issue? Affected a block. Oh, okay, that's such a silly mistake. Yeah, basically, as long as there are any functions in this list, then we will iterate here. And here, first of all, we have already, when we have already copied all of them, we'll first of all we will assign the to resurrect list to the list of the function that we are already resurrecting, and then we will set this once again to an empty hash set. This is not the most optimal solution. Like, I could probably do something here with std swap, but it's not currently the bottleneck, and it's not probably going to be the bottleneck, because currently the bottleneck is the optimization. I am currently also doing a complete rework of the way optimization works, because my previous optimization engine was quite slow. It was a very dumb solution. It basically recognized certain patterns of operations and replaced them with other equivalent ones that were slightly better, but like, it was a very inefficient solution that also has many problems and limitations. So I'm currently moving everything to a new representation, and that's way better for optimizations, and it is also way harder to make mistakes with. Basically, previously I stored all the operations in a single array, and now I have kind of based my representation on the way the common intermediate language operations actually work. Like, so my new representation is basically a tree. Instead of an array of operations, I have a tree of operations, which makes certain bugs way harder to like accidentally introduce, and it's also far easier to optimize stuff when it's laid out in this fashion. It has its own issues, like for example, it makes a very small amount of optimizations impossible, but those optimizations are not all that often beneficial. Like in theory, yeah, they save some disk space, but I don't think they are all that good. Basically, I can't use the duplicate instruction, which would make which doesn't work in terms of trees, because the trees work on an assumption that every operation has certain inputs and produces one output, one or zero outputs, and the duplicate instruction has one input and produces two outputs, which makes it which would mean that my tree would like have two. Normally a tree has like a lot of branches and one root, and in this case I would have a tree with less like with more roots. I could have a tree like with 5 roots, which would be kind of I don't think you can represent that using a tree. Like, that wouldn't be a tree anymore, it would be a like some kind of bidirectional graph, and or it would be a graph, not just a tree, but a more general graph, and a lot of work would get harder. So I can't use this particular instruction, but it's not very used by the C# and F# compiler all that often, and in the future, like, I could probably find a way, but for now I'm like moving to a slightly better representation. Like, the benefits are like drastically outweighing the cost. Okay, anyway, where were I? Functions, and we will set functions to this resurrected set. No, to the alive set. Okay, and this should basically be all of it. Like, I'm pretty sure that I probably made a mistake somewhere. Let me first test the. Okay, let's first look at the add function. Okay, it's not going to remove all that much stuff, but it's going to remove some intrinsics, I believe, like volatile load, like Rust alloc and dealloc. We are not allocating any memory, so it's quite likely that all of this will get slowly but surely removed. And currently, how long is this file? Let me quickly turn on lines. Where is it? Oh. I could have sworn there was an easy way to turn on lines in this. Okay, anyway, I can just use like something else, like the word count. Okay, so vc to be test arithmetics add.io. So it currently stands at 1208 lines, and after I do that, it should be slightly smaller. Like, in this case, it will be not all that much smaller. Okay, so something broke. Okay, no entry point found. Oh, I understand. I made a very, very silly mistake. I should probably swap some stuff around. Basically, this is I have chosen the Rust entry point and not the .NET entry point. I have like a wrap around the Rust entry point. And there should even be a function here somewhere that creates wrappers around entry points. I may have used it somewhere else. Entry. Okay, so in entry point, where do I call this? Yeah, this is like the place in which I generate the wrapper, but I need to find at what point did I call it. Oh, so I call it at set entry point. Okay, so when the entry point is being set, then I create the entry point wrapper. Maybe I should have saved the wrapper here. Like, how often do I use? It seems like I'm using it almost exclusively here. Yeah. In set entry point. I also use it in join, but it doesn't really matter, does it? Yeah, so I could probably just use the wrapper. Yeah, so this was like a mistake. I should probably have used the wrapper from the very beginning. I don't see why. Okay, so it. But I can always check its call site first. Move this here, and it should now all work. And this should be like smaller, and the example with the standard library should also be like way smaller, like very much noticeable. Cargo test std. I'm building it using my test harness. Oh, okay, let me see. I'm currently building it using the test harness instead of building it directly, although you can build it just from the command line, like the cargo. You can use the cargo integration to just use cargo to build, but I prefer to run all my tests from one place. Okay, release and still 8 megs. Let me delete the target to force it to rebuild everything. I'm not sure what happened here. Like, why didn't you remove anything? Okay, and what's the word count here? Okay, so it dropped 200, like 200 lines worth of dead code. It's not a significant change in this case, but it's still should be noticeable. Okay, so it failed. That's interesting. Or at least it seems it has failed. In debug, it should have produced an executable, but it didn't. So there is a mistake here somewhere, probably in the linker. Okay, assembly 605. I panicked at assembly 605. Okay, so I couldn't get some references. Huh. Why? Oh, I have a rough idea of what might have happened here. Yeah, so this might be an reference to an external function. That's kind of interesting. Do I eliminate that code before I... No, in theory this should work. That's kind of interesting. Well, okay, maybe let's do this. Should be like a log function, I think, or inspect for like logging. No, because I don't want to inspect it. I want to display something. Unwrap all else. And here I will panic with the message I could not resolve reference. Okay, and that should be it, I think. Let me test that again. Okay, and at the very end, call site. Oh, so this is like a built-in intrinsic function that I didn't replace. Okay, so that also tells me something. Yeah, syscall. So it's like libc function, I think, or like in POSIX environments. I may be very much wrong, but let me see. It's on my list of functions that are okay. I now understand what's happening. Basically, this function is implemented using the platform invoke. Basically, it's a dynamic. It comes from a dynamic library, so I have to somehow account for that. That some functions come from dynamic libraries, and I may not be able to reference them. And they should be in the external function list, so I'm in luck. Yeah, it should be relatively easy to find them. Like this external fns is just for that. So okay, so I could have something like that. If alive dot no, if this reference, like if it's okay, so first of all, I may try to get this. Okay, I may just use if let sum method here, and I can just do that, like add it, and I will also have an else clause in which I check if this is okay, like if it can be missing. So I will do that by checking if its name is on the list of functions that are implemented in libc, because I am basically all references to libc functions are like they are implemented in libc, so they are not implemented in assembly. They are implemented using the platform invoke API. Basically it tells the .NET runtime, okay, instead of calling an internal function, call a function defined in this particular shared library. So we'll then check if reference if that's kind of yeah, I defined that here. I would have to move it somewhere. Okay, did it get moved? Oh god. Oh, VS Code being VS Code. I see. Do I have to restart it? Or what? It seems to be responding to some window events. Oh my god. VS Code being VS Code. Okay, did it get moved? Nope. Of course not. Yes, I want to do that. And then I will have to make it a public library module. Pub module native pass-through, and here I will, in the linker, I will basically just reference it. I think it's in main. I somewhere reference this list. I think in auto patch. Yeah. So this basically has to be create native. Oh, I already have this logic implemented here. If this is equal to ref name, else if it's not defined here, then I will panic, because then it's a real bug. But if it's in this, if it's one of the libc functions, that I don't have to do anything. In the future, I plan to make this slightly more complicated, and I plan to allow to pass the linker arguments and allow the linker to link to any shared library. Like this kind of, it could help with testing, and it could like, it's a good feature to have, but for now I just have hard-coded libc functions that are allowed to be, that are automatically resolved to libc. Okay, so if it's a libc function, if it's not a libc function, then we'll panic. Ref, and then I hope this fixes this issue. Okay, and let's now rebuild everything and hope this works. Okay, so still something has failed. Question is, did it fail in a good or in a bad way? Couldn't resolve reference at 605. Huh? They did not register the fact that I rebuild everything. That's kind of weird. Cargo, build. Oh. Maybe it like builds some of the stuff, but not all of it. Weird. Oh, there was an error. Ah, it couldn't build the linker. Well, and now everything should work just fine. No, it shouldn't be crate, it should be Rusty cogency there. Okay, and it should now build everything perfectly, and then yeah, let's rerun this test. Okay, now they're running for way longer, so I hope this actually worked. Okay, so those are the warnings that are always there. They basically tell me what kind of what kind of stuff. Okay, that's an interesting thing. They basically tell me what kind of stuff needs to be supported in order for the... Oh, don't tell me that I broke something again. Like, why didn't you provide... Huh. One passed, one failed. So... Oh, I looked in the wrong place. Here it is, and it's just 6 megabytes instead of 10. And if I run it, this is the bootstrap Rust executable. Basically, in order for Cargo expects a Rust program, and I provide the Rust program. Just a program that all it does is it copies the assembly, like it stores the assembly, and here you can see it saves the assembly next to it, and it calls the .NET runtime to run. So it's like a very, very simple stuff. And it dropped from, I think it was 8 megs the last time to only 2.3. So it's way slimmer, and it should be way, way easier to debug. Like, this is greatly cut down. There is a lot more stuff that I want to do. Mainly, I would like to extend in the future this to also deal with types, because this now will contain a lot of rubbish types that are not needed. And if I could do the exact same thing with types, I could... How long has this taken? 50 minutes. That would be a bit pushing it a bit. But yeah, I would have to first... No, like the algorithm itself is very simple. So I could have, first of all, eliminate dead functions. I think I could quickly make this algorithm work with types too, because like it's a very, very general algorithm. Okay, so this will basically call self.eliminate dead functions, and then it will call self.eliminate dead types. And when this works, well, I will be able to greatly cut down the assemblies and make them far easier to debug and to discover all of the weird issues that I'm pretty sure are hidden somewhere. Okay, so first of all, I want to, instead of self.getExported functions, I want to do self.functions and dot. I want to have like this. I call all the non-primitive types .NET types because of the way they are implemented. Because they are implemented in .NET. Okay, so now I could look at a method and do add another thing here. Okay, and this will return a list of .NET type references, and this will be basically, first of all, I want self.sig dot inputs dot eta, and then I want to filter map do a bit of type. Okay, and then I want to zip this iterator with yet another that will do here. Okay, that will do. Okay, for outputs. No, outputs should also be contained in the local list due to the way stuff works. Because okay. Oh, so here I have to do that. Okay. Import that. And it returns the wrong thing. Why does it yield that? As .NET. Huh. That's kind of weird. Yeah, basically this whole algorithm this is kind of stupid. So.sig. This is a really stupid solution to get the output too. Like, I'm pretty sure this should cover the output too, but I want to be extra safe. And yep, and okay, what's your issue? Oh, it shouldn't be zip, it should be like append? Extend? What is it called? Chain, yeah. Not zip, but chain. That's your issue. Okay, so basically that. And wabam, what's your problem? Captures a lifetime that doesn't appear in bounds. Is like a quick fix? No. And it's a bit nasty. Plus A here. Hey. Okay, I can just return a vector. Like, I'm not that bothered to have the perfect, most optimal piece of code. I can just collect here. It would be nice to just do it using iterators and temporary variables, but okay. Unallocation and O2 is not all that bad. Self.functions.eat maybe values dot map friend dot And okay. In this case, I want them to basically be, yeah, I want to get the filter map here. Okay, I should probably, so here I want to get only those which are defined within this type. I want them to be mapped into type definitions. I believe I have my type definitions in a hash map, or if not, like this is something I could still leave for. Oh, so I have them defined by the names, so this shouldn't be that hard. So first of all, I want to filter them into their names. I will do type. Okay, so if, what is the vec? I would like to flatten that. Is it possible? Okay. Okay, so if the type dot assembly, or I should probably just mark that if it's some, then return the type's name. If it's none, no, if it's some, then return none, because I want only those types which are defined within this assembly, and not an external assembly. Really simple stuff. And now I should have a list of their names. And based on the list of their names, okay, that's kind of what happened here. And based on the list of their names, I can turn them into type definitions, because I can just do dot map self dot types get, can here have a name, and I can wrap that, and now we have a, okay, also I would like to also clone that if it's okay, and then collect that into a vec, or maybe into a hash map. Map that into a name. Huh, yeah, I could do that, probably. Okay, so I should probably clone that within here. Clone. And here dot clone. And I can change this to hash map, I believe. At least I hope. Okay, so here I have a set of, not maybe too old. Okay, now everything works. So I will add this to the alive, and in here I want to basically do the same thing, but with the types they reference. Okay, so here I want to rename first of all this from function to type. What? Why didn't you type? Oh, because it's a reserved name? Okay, that works. List of calls, I will do fields, and I will basically do the same trick I did here. I basically map it as, do a filter map. That works. And I will copy all of this boilerplate here. What's your issue? I just have to iterate over that. Oh, one. Okay. Should be plugged. Okay. Why? Okay, so because this returns. Okay, yep, and now that works. Okay. So now we also have to do this simple check. First of all, no, we already get a collection of, yeah, we already get them. So we basically need to add them to the to resurrect list, I think. Yeah, that seems quite simple. Basically the same general algorithm, just ported to work with types instead. Okay, so instead of that we'll have a name and type def. That's simple. Huh. And what's our issue? Cannot infer the type. What about now? Still can't infer the type. Self.types equals to alive. What's your issue? Expected. Oh, because it expects a slightly different type. Okay. Name. Okay, so here I should change that to immutable string. This is basically a type I defined in the cases where I don't need the type to be mutable. What's your issue? To resurrect insert. Okay, I can just copy that. And what about that? Still. Type annotations needed. That name. What about now? Type annotations needed. Why? How? How do you need type annotations here? I already provided them. I want you to cast this to. Okay, maybe here it means. No, you can't provide those here. Huh. Let me just run cargo. Okay, so what's your issue? Can't find a variable name this scope. Oh, I just deleted. No, I did that later. Oh my god. I can't infer type. I provided the annotations, didn't I? Huh. Oh, because I just needed to clone it. No. What's your issue? Huh? Huh. Maybe that will work. So, oh my god, so is it about the allocator? No, it's like, what's happening here? Oh my god. That's so weird. Oh, because I have a collect here, oh my god, and that was all about that. And here I basically have to do an into. No, oh, clone. Auto. And here I have to have a reference, don't I? No, what's the issue? Okay, so here you want an immutable string. Oh my god. And that should fix that up. No? Okay, so here now wants a reference and... Okay, the exact same... No, why? I will just clone here for now. Like, this runs only once, and I'm pretty sure this is one of the still fastest parts of the whole compiler modules. Like, I'm not all crazy about performance right now. Oh, and that should eliminate all the types that are not referenced from anywhere. Let's try that and see how it impacts the size of the final assembly. Maybe we'll get it into a much more reasonable place. And okay, it seems to have still worked. 2.3 Q6. Okay, let me first delete those to be sure that they are not like left over from the last. Okay. Huh. Maybe most of those types are needed after all. Okay, so it didn't seem to have that big of an impact. It had an impact, but out of memory, yeah, I know that. 2.3 megs. Okay, so I cut down on the size of the assembly significantly. Yeah. Let me run some tests to ensure that everything works as expected. And that should be probably it. If nothing pops out, okay, a lot of stuff seems to be failing. That's not good. And it was not failing when I was not removing types before. What's your issue? Oh, so it removed Rust. Oh, I know what's happening. Because this type is never really referenced because it's used in some very, very specific places. So I can just add it here. Insert salve.times get void and yeah, so here I can just do into, and here what's your issue? Option. Okay, so I can just do clone, and this should fix it right up. Yeah, this is basically this particular type has to be defined for the runtime to be happy, but it is represented as a variant of an enum here, like as the void. Okay, so test stable, and let's check if some of them still fail. Why? That's the question. I assume. Huh. Okay, so here it. Okay, so it seems I have messed up something else. Yeah, assembly 641. So yeah, with types I will probably just leave that off for now until I can get it more polished. But it's good to know that I at least have a skeleton of that working. Okay, so there still seem to be some weirdness even with type and type.code and elimination removed. Test CF4. Okay, now that may be not related. I'm not sure if I have updated this particular branch. Okay, I will have to look a bit more into that. I think I know what's it. Probably maybe with the change related to me switching up to a different representation, and because of that I have to rewrite some functions. Okay, so I feel like that's something I will fix up during this week. Like, I don't think it's a big issue. Like, I had it working before and it doesn't work right now, but I have a rough idea of what the cause is. So I guess, yeah, I think I haven't pushed one change from another account. and I have not synced with the repo, because I think they have fixed this bug already. Like basically, I think I am loading the value of a field instead of its address in one place. Okay, but I feel this is like a very good place to stop.